Thanks very much for having me back here. I often do panels about artificial intelligence, and I'm really, very, very sort of humbled by being on this panel and helping moderate this discussion with these three incredibly smart people that know everything from data science to artificial intelligence and beyond. But really, artificial intelligence to me is incredibly interesting. When I was chatting to Carolina, we were just saying just a few years ago, AI wasn't even being discussed, right? And now everyone's discussing it, everyone's interested in it. Researchers are saying that within a few years, 2025, that there could be like a $15.7 trillion impact on GDP globally from AI. The way that products are built, consumer demand, the way that we operate in the world is going to be affected by artificial intelligence. Every system that we touch, it's going to be there, hopefully making things run a little bit more smoothly. Now, there's lots of dialogues about the positive nature and negative nature. We're going to cover all of that. The last 15 minutes of this session, we're going to open the floor, and there's a microphone that's going to be available to be passed around, and there's also a microphone in the middle. So when I say, we're going to open questions to the floor, then I'm going to invite anyone to either raise their hand or step up to the microphone at that point. So do think about some really hard questions or some anything that you're really curious about. I'm going to address the pizza thing head on. Right? My favorite pizza is Hawaiian. That's controversial to many people. And I was thinking, what about AI? Would AI enjoy pizza? Well, I'm sure it'd have a couple of bites.
Oh my God.
Oh. You're welcome. That took me a whole 5 minutes on the plane yesterday. Anyway, so we're going to get into it, and I'm going to ask everyone to introduce themselves. Just speak for 1 or 2 minutes about who they are, what they do, and their sort of position in the world on artificial intelligence. So over to you, Sawinder.
Yeah, thank you, Nick. Thank you for having me here. Hi, everyone. I'm Sawinder. I'm a data scientist expert. And so about me, I'm a PhD in applied mathematics, and from past some years, maybe 9+ years, now I'm working in this field. I'm a little new to SAP, like SAP is like 2+ years now. Before that, I was working in Shell. So throughout my journey, I've worked in various fields, and currently I'm focusing on telecom data, where we're building this machine learning product, and that's about me.
Cool. Over to you, Carolina.
Okay, so thank you, Nick, and thank you, organizers. I'm Carolina Bessega. I'm the Chief Scientific Officer of Stradigi AI. Currently, I manage a team of 26 researchers in different areas of artificial intelligence, mostly machine learning, but we have groups in reinforcement learning, recommender system, natural language understanding, image and video understanding, and time series analysis. And I have been working with artificial intelligence since 2002. My background, I have a PhD in astrophysics. And after that, I moved to work at a university as professor in a group that was called complex systems. So what we were doing there was solving problems with a lot of data, and that happens to be with machine learning. So from there, I have continued my journey up to here.
Thank you.
Hi, everybody. I'm delighted to be here. My name is Doina Precup, and as for my background, I'm originally Romanian. I moved in '95 to the States to do my PhD. I did my PhD in computer science, studying reinforcement learning with Richard Sutton, who's one of the pioneers in the field. And at that time, machine learning was quite exciting. And then I got a job at McGill University. I moved to Montreal in 2000. I've been at McGill since then. All the excitement kind of died down for about 10 years, which was really good for me because there was a quiet time to actually do good research. And so now all the excitement's back. And in fact, as of last year, I now split my time. I'm half-time at McGill and half-time at DeepMind Montreal, where I lead the research team. And also, our lab at McGill is fusing with Yoshua Benjo's lab to form Mila. So I'm part of that endeavor as well. So I wear many hats these days.
Thank you so much. So we've got an incredibly qualified team here, and really, I think where we begin is at the beginning. You know, we could start off by saying what is AI, but I think that's going to come out as we discuss. I think what's more interesting to me is to actually think about what does it take to build a good team and a good capability to be able to start looking at artificial intelligence and also from data all the way up through to the algorithms and training and whatever. You know, what does it take? And I'd like to sort of draw on some of your experiences in the teams that you are actually running. And maybe start with you, Sawinder, in terms of data science and whatever. I mean, how do you guys approach a problem with artificial intelligence?
See, we start with a problem, a simple business objective, and then the first thing is let us understand that objective. I mean, it's a lot of iteration with my end user, with my customer, and then we start putting our heads that how I am converting it into let's say a machine learning problem. It might be a pipeline, it might not be a straightforward thing. We have to put certain logic, certain algorithm, and that's where the journey starts. And everybody in my team is involved in the sense my POs are there, my data scientists are there, then we have our developers are there, UX designer are there. So all of them, we work together to make it as a product. So that's pretty much the journey is there.
So the journey in terms of like starting with the problem.
Yeah, starting with to understand it, what the end customer is asking for, and just to see, I'll say once we understand the problem, it is half solved.
Yeah, okay.
So understanding is understanding the business objective is the crucial thing to start with the journey.
So I want to just expand on that, starting with the problem. We talked about that as well, Carolina. If we do start with a problem, how do we know that that problem is best served by artificial intelligence?
Well, there are different kind of criteria, and in fact, for my business development team, I have agreed with, okay, how do we know if this problem can be solved with AI? So I think that one of the first things is that the solution needs to be in the data. So it needs to be a problem where you have data and you think that the answer of that is in the data. So that's the first thing. I will say that the second thing needs to be a problem that has some margin of error. AI usually is not 100% accurate. So if you need something that needs to be done for, I don't know, engineering, and need to be exactly and precise, maybe AI is not your thing. Needs to be, you need to see what is the state of the art. So once I get the problem, so usually the way we work is exactly like you have our business analyst, we get the problem, we understand the problem. Now the problem goes to our research team, and we brainstorm, what is the best way to solve this problem? Those are very funny sessions. We go do literature review, find what is the state of the art, and with that, you can have an idea, okay, other people have done something similar. We think that this can be solved with the current state of the art. Because a lot of things maybe can be solved in 10 years, but what can be done today? And that is important to understand.
What are your thoughts on this, Doina?
So the data is really, really important. And at least on the McGill side, we do a lot of applied work, especially in the medical domain, both with companies as well as with doctors in the hospital. And it's never a case that somebody comes and hands you a data set and says, here, now go do machine learning and bring us a model. It never works that way. Those kinds of projects fail. Yeah. You really need whoever the stakeholder is, whoever wants this problem solved, to be in the loop. And they have to be there when you define the data set, when you define the objectives. They have to be there to see partial results so that they can give feedback and say, okay, this is useful, this is not useful, this is what we would expect. Why has this model done this particular thing? So we often work in a team where there's students, and then there's the people who understand the problem and can point us to where the deficiencies are. And it's really a closed loop system.
So, I mean, you talk about stakeholders, and sometimes we know that stakeholders don't really know exactly the methods and techniques that you use, and they're like, just fix it, please. Yeah? But how do you go about educating them and their teams around what the possibilities are?
Yeah, so that's a great question, and it does take time. my best collaborators actually have been my collaborators for 10 years now. And it took a while, right? It often takes a few months of meetings to explain the terms, to explain some of the method. They don't need to know the details of the method, but they need to understand what's the capability and where would we expect this to work. In some cases, there have already been examples of successful machine learning in these fields. And so they're already convinced. So if they come at the table with a positive attitude, yes, machine learning should be useful, then I think half the battle is won, because then they're going to have the interest to listen to what we have to say in terms of descriptions of the methods. I think in the research community, a lot of us would like to see our methods be more explainable and more interpretable and structured in a way where somebody can understand easier what is going on. But we're still very far from that, and at the moment we're still working on performance much more than on these other aspects.
On the understanding.
Yeah. So I'm going to give like an example of how important is this communication with the stakeholders. We were working in a project that was to classify heartbeats to find cardiac arrhythmia. So if somebody has atrial fibrillation or any other kind of arrhythmia. And when we were solving the problem, we need to find some kind of threshold. More or less is a compromise between what was more important for the client, to find every heartbeat where there is a problem, or to make sure that if I say that there is a problem, it's for sure a problem. So these are two different things, the precision and the recall. And took us, I think, like a month and a half to be able to have this common language with our client that was a medical doctor to understand what were the difference between one and the other. At the end of the day, we found an agreement, and we found, okay, for them, was more important to identify every single time, no matter if sometimes make a mistake and he has like a false positive. But this is the kind of thing that is important to have the stakeholder in the loop, because a lot of times you need to do compromises in the results that you are getting.
Yeah. I just want to turn to you, Sawinder, in this as well. You said that you're working with telecommunications data. I mean, very, very large data sets. I started in telco billing 20 years ago, and I know the pain that comes with that, you know, data off of switches and rating and whatever. Sometimes you're not given a problem to solve. Sometimes you find problems. Yeah. So how does it feed into artificial intelligence solutions when you go through and you do the data science? You know, what's that process? And when you find problems, how do you take that to the customer to persuade them?
Yeah, that's actually a good question, because winning a customer's trust on solving a problem, it's always been challenging. So let's say we have found a use case, and now we are solving it using a machine learning, and we found some solution. Now the next step is how I go and tell him that, hey, we have some finding and it might be useful for you. That's where the real challenge is. So sometimes if they're aware, I mean, of how the method works, or if they understand, that is an easier job done. But if they don't, then we start with, let's say we start with something like a baseline case, or maybe how they solve a problem. If they are just solving a problem with their domain expertise, or if they are solving a problem using their own methods, then you can say that's my baseline case, right? On top of that, I can have a very simple model just to explain them how this methodology is working, right? And then maybe we can think of improving that model. Let's say I start with a very basic model, which is not that accurate, but it wins my customer's trust. Then first, let's go and show them, just to win their trust, that that's how the machine learning is working, and that's how you're going to improve your efficiencies. And once that is there, then in the second iteration, we can go and we can improve the model. So it's as I'm saying, it's not that easy as I put it. It's a little challenging because we have to explain a lot of them, right? They are coming from their domain, they have their own domain experts, they have their own pre-notions and everything. However, when they see this change, the efficiency improving, that's where I see that, yeah, it is working. It is working.
Is there a specific example you could say?
Okay, so maybe let me think. So, okay, so we were working on this feature selection problem. So this is what it is. So what they are currently asking for is something like this started. Like, give me those products or give me those services that are not profitable. So that was the statement that was coming out, and we just want to find it out. And we said, okay. So we started looking into our data. We were looking at the features and how, whether they are profitable or not profitable and all that. And then what happened is, while doing that analysis, what we found is if we look at the combinations, if we look at the interaction between those features. So for example, if it's a female and the usage data, or maybe if it's a female from Germany, it's profitable. It's a female from, let's say, Bangalore, it's not that profitable. So these kind of combinations where I'm finding the combination of two features or three features together, and all of a sudden what we see is now I am finding the profitability different from when I just look at the one feature alone. So that is a different from what they were thinking. And then we took this and we showed them this comparison just by simple statistics, simple things, that's how the comparison looks like, and this is what you are getting an advantage. So that's where we saw the things were more positive, and they were like, yeah, this is something nice, and this is something we wanted to look at it. So that's a little step forward towards winning their trust.
So data science mixed with machine learning, finding the new areas and new direction for inquiry and hypothesis setting, right?
Yeah.
Yeah. I just want to pass that question on to both of you for other examples as well, because I find that's really useful to understand the process.
So there's often cases where somebody comes with a problem and they have sort of a hand wavy a little bit way of looking at it, but it does rely on data. So again, in the medical setting, this arises, for example, when you have recordings of signals, perhaps in the emergency room or in the ICU. And typically what happens is a doctor will walk in, they will look at the recording for a few seconds because they don't have very much time, and they'll say, yep, this is going on, let's change the treatment this way and that way. But there's never a capability of the person to be there 24/7 because just the healthcare system is not set up that way. And so they use the data is there, the data supports the decision, but there's a limited amount of bandwidth that they have in order to process the data. And so in some sense, that's a very good place for AI and machine learning, because you know that the data exists, you know that the data is useful, and you can structure the problem in such a way that they get perhaps an extra tool that helps in the decision-making process. Now, sometimes it's also an interesting question, how do you best deploy that tool? Because there are trust issues, and there's also just issues of user interface that come up that honestly AI people don't know very much about. And so, for example, in a clinical setting, when we started working with doctors, we thought, oh, you know, doctors like to have alarms. It turns out they really, really hate alarms, right? Because something's beeping all the time, and they most of the time ignore it. And so you need to have sometimes also people who figure out what's the best way to present the information. And so I feel while AI is doing a lot of the heavy lifting in terms of the data analysis, there's a whole layer of other stuff that has to go on for these kinds of applications to be successful.
Yes, I want to touch on that point. That happened to us too in a project related with sports. And we were basically doing analysis on a lot of things, on tactics, on drafting, and we were providing a lot of results. And one thing that we noticed is that one of the most important things, additionally to do the models, was to create very, very good user interfaces adapted for different stakeholders. So for example, the coach is not interested to see the same information as the general manager, or even information that needs to be given in the right context. So AI, and I have said that in other conferences, that AI is not only the researchers. You need the researchers, you need user experience, you need, for sure, like engineers, front-end developers, mobile developers that are the ones that are going to be the interface between these models and the public.
I mean, so it's really interesting you talk about all these different developers and whatever, because AI eventually touches a customer somewhere. How do we've seen AI sort of raise its profile, but this is because it's starting to come into consumers' lives. I mean, where do you think, in terms of, how's that changed an approach to AI itself? Because we do know that the data science and building the models and then finding the problems, it stays internal, but then it touches the consumer. What do you think the consumer actually touching artificial intelligence and machine learning on a mobile device, how's that going to change artificial intelligence?
So that's a great question. I think part of what's happening is there's more need for privacy and security to interface with AI systems, right? Because once you start touching consumers, they may or may not want their data used in certain ways. And the interesting thing about machine learning, of course, is that the data gets ingested inside the model.
Right.
So it's not as simple as saying, oh, if the customer has opted out, now I'm going to like remove the record from a database, and with this I've solved the problem, right? There are data as part of a model, and if I can identify something about that consumer by querying the model, that's a problem. So I think that's changed the thinking of machine learning researchers in this direction of thinking about privacy issues, thinking if there are technical solutions for privacy issues. And it turns out that actually some of these things really, in fact, have the potential of making the learning algorithm better also. Because if you are not sensitive to minor tweaks in the data, such as dropping a customer or putting a customer on an extra customer in, then actually your algorithm is more robust, so maybe it just works better in general. So that's sort of a big area where I think the interface with customers has kind of changed the thinking. I think on the other hand, there's a lot of techniques which in the research community we consider to be working very well, but where we need to see even more improvements in order to have them work well in a practical setting. We were talking about chatbots, right? So natural language processing and dialogue systems is a big area where there's a lot of research interest. There's been a lot of progress. Like if you look at all metrics of queries and dialogue satisfaction and so on, they've all been improving, but still the systems are not at the point where you really want them interfacing with millions of people every day, because they're still kind of too slow and too clunky. And so I think that whole research area is quite interesting as well.
Yeah. Any more thoughts on the consumer touch back into AI?
No, I want to say that ethical considerations of AI are super important. Data privacy is one of them. Another thing is the bias, because this algorithm learns from data. So you as a researcher or the company who produces the product need to make sure that the data that you use to train was not biased, that the algorithm is not going to take a decision based on the wrong information. This is especially important when you have algorithms that have continuous training with data that is injected all the time by users. So you have a customer is clicking here, there, and this is automatically injected in the system. How you can make sure that with this being deployed, still your data is relevant, there is not bias there. So these things are very important and are considerations that researchers are taking into account nowadays.
Yeah, same as she's saying, and testing it in a different scenarios, that's an important aspect that, it has to be robust enough, right? So that when I'm deploying it, we look at it, we test our algorithm in a different scenario, how it's going to behave. And so that's an important aspect of it.
Yeah. So I've had many conversations over the past couple of years with many researchers, and transparency, right? And also the regulators out there as well. Like, tell me what that model's doing, right? And versioning and whatever. If we start off with a model like today, and over the next 3 years the model evolves and develops and provides us with more insight and more direction to our strategic sort of operations. Like, how do we communicate how things are changing to the consumers, but also to the regulators? It's a big question.
It's very tricky, right? Because especially because it's not just about the mechanics of the model, it's really about the data sets. And sometimes the data that we produce will be different and will shift, right? The fact that the system is implemented somewhere in an organization may generate different data than the organizations otherwise would have the capability of analyzing. So there's unfortunately not an easy answer.
Sure.
I think that a lot of the AI companies would like to have a continued discussion with regulators, in fact, in terms of what are the best ways to do this. There are some issues which are more black and white, ethical considerations, right? Do no harm, these kinds of things. But a lot of it is going to be much more nuanced in terms of providing explanations. And in some cases, I feel like perhaps we are holding AIs to a higher standard that sometimes we hold people, right? I mean, people make decisions. They have their motives. Sometimes they explain something, but it's not the real reason. Maybe they even believe they explained it right, but it's not the real reason. And so I think once AIs become more complex, their behavior becomes more similar to people's behavior, and it will be harder to justify their actions, and we will need essentially a framework for deciding, if there's something that went wrong, whose fault was it, and how to deal with it.
Yes. So I want to say that at least here in Canada, the government is very worried about that. There was a request for information from the Treasury Board about AI and in particular about ethics. There is also an assessment called the Algorithmic Impact Assessment that they are testing, where basically the idea is to when you produce an AI and that AI algorithm is able to harm a human being or a sentient, let's say, not necessarily human, an animal, or this AI needs to be regulated. The problem is how. So the problem is, the debate is, what should we do? Should we do peer review? Should we do periodic tests on the results? Somebody should audit the code. For example, audit the code is something that I really, this is my personal perception. I really don't think that you are going to be able to spot anything there. I would prefer audit the data and the results. But these are big concerns. How can we make sure, for example, if it's an algorithm that is going to be used, I don't know, to do cancer detection, should this be continuous learning without being checked periodically? Should it be retrained by a human, tested, and after deployed again? So all these are concerns and questions that regulators need to work harder and faster. Because one thing that worries me always is that if the regulations are not ready, the good AI probably is not going to go out. And maybe some people doing some more harmful things under the table, those ones doesn't get penalized. So it's very important regulators to act and to go at the same pace than the technology, which is difficult.
Yeah, I mean, we need to understand that everything is working based on some data. If my data is changing, if the nature of my data is changing, my output is going to change. In AI, that's the thing. It works with the probabilities. There is an uncertainty factor involved. So if my data is continuously changing, I need to keep track of that. And I mean, regulators should also keep a track that how often the model should be changed or improved or iterate over it. So that's something to keep in mind. And of course, in where the false positive matters a lot, there I think, yeah, there has to be some manual intervention or some sort of a checkpoint to see that when my false positives are going above then a certain threshold, and can I afford that? So these kind of things, I feel it has to be a regulatory effort that has to put in place.
And this makes me think about autonomous systems versus systems that have got a lot of oversight as well, like closed systems, self-driving vehicles, or surveillance systems or whatever. And this also makes me wonder about ethics. Ethics in a situation like ultimately in an autonomous system with artificial intelligence, and there's a lot of fear in the world about these systems. Ultimately, someone's responsible, But when it's a closed system, who's responsible? Is it the developer, the data scientist? Is it the person in charge of that project? I mean, discuss, right? This is a big question around ethics.
Yeah, I mean, this is a big question that I feel, in fact, does not belong to the AI community. It's really a sort of a legal and ethics question, and so we need help. In all honesty, we need the ethicists and the lawyers to come and help us reason this through. I think there's right. One of the questions is there's an issue of agency. I think in legal terms, like who's the thing that's making the decision? Is it the AI? Is it like what's the impact of the developers in that picture? But I think this is a place where really it's not the technical people that need to think about it. It's really the ethicists and the lawyers. And Quebec, in fact, and Montreal are very well positioned for this kind of thinking. Right? Quebec has started this observatoire of artificial intelligence with the goal of making this a more international organization. And I think there is a lot of interest in the ethics and legal community for people to look at these things and really think deeply about them. And I think it will take a few years to iron these things out, but I think at least we're on track. You know, this has become an issue that's on the radar of government and also of people who do research in this field.
I mean, how often do you work with ethicists?
I'm a member of the AI ethics meetup here in Montreal. So I meet with them every 2 weeks when I can go, but I usually try to go. That's a great group, by the way. It's free. You can find it in the Meetups app. Great group. There is technical people, lawyers, philosophers, and we talk about this accountability, impact assessment, and all the things.
Yeah. And Sawinder, earlier you were talking about telco data. You're saying a female in Germany, maybe a female in India, and whatever. But you know, some of this could actually build inherent bias into an AI model, right? Yeah. So how do we deal with this? Because we are just the data scientists, we are the developers, we're still taking direction, but that direction could actually build something, or we could find information that does build bias into the model. I mean, how do we deal with that? That's a real hard question.
Yeah,
I understand.
That's ethical.
Yeah.
I mean, it's a quite challenging question, and I'm afraid I don't have a very straightforward
right.
answer for that. I mean, but see, from my point of view, I have a data. It's just numbers that are telling me all that, right? I'm feeding it to some algorithm, and what is coming out from it is just we are recommending it. One thing we should keep in mind is how I am going to present these results. See, there is a positive way of telling the same and negative way of telling the same. However, at the end, this is what the data is telling me. That's how I'm going to report it. If my data is changing, let's say the next time when I get a new set of data and I iterate over and get a new insight, maybe then I'll report it accordingly. But I mean, I don't have an answer. If my data is telling me that, I'll just say that this is what it is.
And this is where the blur happens.
Exactly, but that's a very difficult question, like to answer.
Machine learning will take us in certain directions. I mean, there's one example that I talk about when I'm out there, and so in the States there was some machine learning algorithm learning about insurance and risk, and it was processing paper applications. And it was discriminating against people that had bad handwriting and were living in particular postal codes because it assumed that they had a lower level of education through the machine learning and actually were biased against them, which is terrible. And you're not allowed to do that. You're not allowed to do that under the regulations in that industry, but AI was going about that. So how do we put some safeguards around this to ensure that we're not breaking those regulations, even though we're kind of learning, bias in the system that on occasion may be right, but can be equally as wrong.
So I'll share one example. So we were working on this project, and it was like we wanted to learn how a particular student is going to perform in a course, in a discipline that he's taking, or maybe in a major that he's taking, whether he's going to succeed or he'll drop. Right, so that kind of a problem we were working on, and see, if he is going to do well, that's good, but what if my algorithm is telling me that the student is not going to perform well, and he's going to fail or get a D or something like that, then what do I do? So should I not let him enter into this discipline, in this major, or should I do something else? So that was a question, right? So in those scenarios, what we decided is, let's take these insights that machine learning is giving me and use it as to improve what a particular student can do. So let's say if my algorithm is just predicting that, yeah, he's not going to do well in this particular, let's say engineering major, right? But I know that engineering major is related with this course A, course B, course C. So if he is somehow able to perform well in course B, I can recommend him that take course B, take course C, so that you will build your base strong and eventually you're going to pass it. So I'm taking this prediction and then I'm helping my student to sort of recommend that what else he or she can do in order to pass this. So rather than just relying on that insight, I can take these as sort of improving the system, or make him understand that this is what my understanding is, and this is what you can do to improve yourself.
Right.
So this is one way to look at the things.
I want to give like a bad example and a good example.
Sure.
So, because the problem is not only because I'm adding some fields related, for example, with gender. So imagine we build an AI algorithm to hire truck drivers. Truck drivers is a profession that most of the time is done by men, okay, traditionally. So if you put all this data you put all the information about 1,000 truck drivers that we have hired last year, and we tell the AI, okay, learn what are the conditions to know if you're going to be a good one or a bad one, probably be a male is a good thing. The point is that this might come also from bias from the humans who were doing this task before. Maybe the human who was doing this, who was labeling the data, who was saying what is the right or the bad thing, was only hiring men, or was hiring men with more probability. So the problem goes further away that, okay, I should take a field or not in my data. It's also, is the data labeled with some bias? So, and that's very difficult to remove. Now, a good example of how AI can work against discrimination, also in the HR context, there is an HR application that I saw done by a company where they were reading, using natural language understanding, they were reading the job descriptions and getting what information there was more target towards men, where it's more like aggressive phrases where you need more like a strong character, that was making women feel shy and do not apply to those jobs. So what they created was an application where you can write a job description, you put that there, and the AI tells you if it's gender neutral or is more catered to one gender or the other. The result from that application is that they had 43% more women applying to the same jobs after they passed their job description through this tool of non-discrimination.
Yeah, I really like that example because it kind of highlights the things that you can in fact do to make it better by leveraging AI. And I think there's, certainly in the research community, there's a movement towards what people call algorithmic fairness. So this is basically a sort of technical way or a programmatic way to try and detect if the data set is biased, if modifying frequencies of examples in a data set, for example, may lead to different decisions being made by the algorithm. And of course, the algorithm won't pass judgment, right? But in such cases, we may want to flag this kind of situation to somebody who's in a decision-making position so that they can sort of provide input in terms of how to restructure the data set perhaps, or what should be done. And there is actually even a new conference that started under the umbrella of ACM, which is looking into algorithmic fairness and what are good technical solutions. the technical problems are actually both fun and challenging in terms of detecting these kinds of problems with data sets, and what are the sort of the right ways to correct them, just from a technical point of view, or what are the right ways to do the detection process.
What's fascinating to me is this is a paradigm change in terms of understanding about, looking at data in a new way, looking at the systemic thinking, and also how it works holistically as it touches consumers and internal systems as well. I mean, how would you go about sort of going from a technical role that doesn't touch data science and artificial intelligence towards getting into that side of things as well? This is a question that sort of came from the SAP crowd.
Yeah, so there's actually sort of two different things that you can do, right? One is you can become essentially an applied machine learning researcher. To do that, the barrier of entry is actually not very high, in the sense that there's now a lot of courses and there's a lot of software packages that are openly available to anybody. A lot of the community really believes in open source, and the papers are online. So just to get your feet wet in terms of trying some machine learning methods on the data sets that you have, or data sets that you're interested in, or just toy examples, it's very easy to do. And a lot of the time, that is what you need, is to understand what's the tool and how do I use the tool, right? You don't need to know the nitty-gritty details of how things work inside, right? So, you have a car, you need to know how to drive the car. You don't need to open the engine up. For that, you take it to a mechanic. If you have a problem with your machine learning algorithm, you take it to an AI person, and they will sort of debug it for you, right? But to learn the tools is okay. The other thing that I would say is quite interesting, I think, is to be more in one of these roles where you understand how and where it could impact the organization and the problems that you're facing. And that is not so much a technical thing as it is sort of almost on the soft side, right? What are the problems we're facing? Do I think this is a good problem that AI can tackle? And I think that actually there's going to be an increasing need for people who have this kind of capability. And that requires, I think, also on our part as academics, a different kind of education. It's much more of a sort of literacy education rather than an education on the technical aspect. It has to do with data literacy, with logical thinking, with understanding outputs of these algorithms and understanding their limitations and also their strengths.
Yeah, I mean, in addition to what she said, I'll totally recommend going a little bit of hands-on. So now we have websites like Kaggle, Crowd Analytics, and where like data is there, and then these competitions are there. There are some that are really for the education purposes, and then there are some that companies, they just post it, one can just go and compete in them. And it's a very good platform to try for the hands-on practices. So I feel, taking a theoretical education, it's good to start, but once we are done with that minimum, let's go and try for some hands-on. That really gives the sense of how the algorithm is working. So that's something people might want to try it out.
Yes, I think that the first step that anybody has to do is learn to talk with the data and learn to listen to the data. And that's an exercise that anybody, you should not, and this is an error I have seen several times. People want to jump to, I want to do deep learning. I want to do a convolutional neural network tomorrow. No, you first need to take your data, start doing graph, start playing with your data. What happens if I modify this? See the statistics of that data. I think that that is the first course that anybody should do, and that includes people that is going to go more towards doing like applied data science, or people who wants to do also project management in the area, because it's very difficult to communicate with one of the researchers. It's much simpler if you communicate with the researchers through the data, if you understand what is in there. So that's my advice. Start by loving data. If not, don't try to go to that field.
Yeah, and I'll say one other thing sort of related to this is, deep learning is amazing, reinforcement learning is amazing, I love it, it's my research field, But most problems don't require this kind of tool. They require much simpler tools. And in most cases, you actually don't have enough data to use a very big hammer, right? You need to use like a little screwdriver, and that will make a big difference, and it'll be sufficient.
Right. And how can sort of artificial intelligence, machine learning techniques sort of feed into, you know, the software development cycle, you know, in terms of just understanding that data and just feeding into it? Because you might not be building the AI to be in the product, but it can be part of the research piece as part of the design.
Yeah. Well, in our case, so we have a research team. When the problem arises, and it's a problem that we're uncertain in what model to use or what combination of pipeline of models to use, that goes first to the research team. When we have a more clear vision on, okay, this is the model, there we involve the software development team. So software development is I will say that within the software developer, the architect and the backend developers are the one that works closely with these machine learning models. So you need to make these machine learning models scalable, performant. You need to make sure that they communicate well with your backend, that to after transfer this data to the front end to do the to show it.
So we need we need to look for the infrastructure in place. I mean, I will say check the infrastructure independently of the machine learning aspect. Just check, see, there will be a data input that is coming to the machine learning algorithm. So how my algo is communicating with the data, how the data is getting input, right? How the algo is getting that input. Once I am done with this entire analysis, then I have to show those results. So that means now I am communicating to the output. I need to show that. So that's where the UX comes into the picture. So this entire infrastructure has to be there, and it has to be checked properly. So maybe some of us, we might be working in mockups and all that. So first that thing comes into the place. Then we see, okay, that's how the algo is taking the data when I'm calling this particular procedure. That's where it is taking the data. Once the analysis is done, that's how the output looks like. I need to parse this output and make a visualization out of it, or make a table out of it. So this entire infrastructure is there that takes place.
Right, I'm going to open and this has been fascinating so far, thank you. I'm going to open the floor to anyone that has questions. There's a question down here at the front. Let's start here, and at the end of this question, put your hands up or walk down to the microphone. Thank you.
Thank you very much. It was a very good discussion. I have a personal question to all of you three. So would you be comfortable in driving in a self-driving car in your hometown at rush hour?
I have a very good answer. If they can test the auto-driving cars in Bangalore, that's their ultimate test for the auto drivers.
So you would be comfortable?
Sorry?
So you would be comfortable to drive? Only after test?
If they can show that this is a very good performing car in Bangalore traffic, then I'll be.
Yeah, I actually don't know how to drive, so I'm really looking forward to the day when there's going to be self-driving cars. I have failed my driving test 3 times, so I know I'm not capable of doing this. I also know it's a hard problem. And I think these systems will be validated enough that I'll be perfectly fine.
Yes. In my case, it's a user experience problem because I love driving. So I will hate to have the AI driving my car, especially if it's a good car, like a McLaren or something like that.
I kind of feel that enjoying driving was something that the car companies persuaded us about, right? I drove across the States last year. It was like 5,000 kilometers, and I tell you, I wish I would have had a self-driving car in Idaho. That was like, you know. I think it's interesting because it's like the urban centers versus the wide open road. I think that's
then even we can't drive in Bangalore.
Yeah.
How will an AI? I mean, it's an ultimate test. That's the only open challenge I'll say to Tesla guys or to these auto drivers.
Yeah.
I mean, come and drive it in Bangalore.
So there you go. Okay, shall we move on to another question? Who's got another question there? There's one over there in the middle. Thank you, Julia.
Thanks for the nice presentation. You mentioned the bias of the application that you had. I wonder if that data scientist could correct the bias through the data before feeding the data to the model, so he can remove, for example, the truck example that provided. Instead of providing the whole data, if he can look into 500 samples from women, 500 samples from men, and then provide that data to the model so he can remove the bias. Is it, should we deal with the data religiously as cannot touch it, or we can manipulate that before feeding the model?
That's a great question, and from the perspective of somebody who works with other people's data, I would much rather get all the data as much as possible and then have the opportunity of looking at it in different ways rather than necessarily having the data cleaned up ahead of time, because sometimes even that process induces other biases that you don't know about. But I think we do need to have ways of inspecting the data that flag these kinds of cases.
What do you do if you find, say you have an entire data set and you know that there's inherent bias, but that bias is going to have a positive effect on the business results?
It's a bias.
It's a bias.
Right? It's bias, right?
Yeah,
But you know, there's still people that operate in business today with that bias there, making decisions based on that, right? So, is it your role to say no, from an ethical perspective, we cannot suggest that you use this data in this way?
I will say in my case, it will depend on what is the impact. For sure, I will inform. So that's for any case, no matter what. Now, if it's for something that is really impactful, I probably will say no.
Yeah.
I will not do it. Yes.
Yeah, but I think ultimately these are going to have to be decisions that are somehow also regulated, right?
Right.
And you know what a business can and cannot do with answers that are coming out of data. And we, in all honesty, have some experience with such fields that are controversial and where things can have positive and negative impacts, right? Genetics is the thing that always comes to mind, where there's great business opportunities, there's also complete mayhem that can happen, and people have found regulatory frameworks, have found ethical ways of thinking about the problem, right? When is it okay to do gene editing? We have the technology to do gene editing. When is it okay to do that? I think it's a similar field compared to AI, and we need to sort of have that conversation just in the way that they have it as well.
Yeah. Setting boundaries through regulation. That's actually a fantastic question. Are there any more questions out in the audience? You've already asked a question.
Hi. I have a question related to, I'm just curious about...
Can you put your hand up? Oh, hey.
Yeah,
sorry,
right over here.
Over there in the corner. Hi, you're in the dark. Hi.
I'm curious about what you guys use to visualize or to get insight into your data before you even try to train a model for it.
Different tools. In general, when we get the data, we use Jupyter Notebooks and Pandas. It's like so nothing fancy. When we're building dashboards for clients, yes, we use maybe some more commercial tools like Tableau, or we do visualizations in JavaScript using D3.js. But when the researcher gets the data, usually we use like Jupyter Notebooks, Python, nothing.
Yeah,
Scikit-learn.
Yes, exactly.
Yeah, same. Jupyter Notebook, I mean, that's, I think, the most famous one. Everybody.
Yes, no fancy answer here.
When I started, I used to wrestle in like old school spreadsheets, and that was even worse.
Okay.
Right? Yeah, we've all been there. That's actually a really great question as well. There's another question down here. Julia's just coming with a microphone there.
You talk about the trust of the end user. Once the application is deployed, how you get the trust of all the end user? Is there any way to get the feedback that some value were not correctly evaluated?
So what we're saying is, how do you get the feedback from the users once the application's been deployed?
Correct.
And how do you get them to test in line, yes?
And you say that UX design is important to provide information, but then is there a way also for the end user to give feedback to the implementation?
I mean, when we were building this new feature about feature selection, we purposely had this place to give us a feedback. So feedback is very important, right, once the model is being deployed. So either we keep a place for an end user to give us a feedback, I mean, right into the app that we are building, or maybe we can, I mean, there were times when we were like sort of on a regular basis, we were in touch with our end user. They were testing it and then they were giving us some feedback. So the idea is we have to make provisions to get that feedback in order to improve my model, in order to improve the model.
So,
Yeah, and ideally, if you can sort of think ahead of time and get permission to look at results as the system is running, very often that becomes very useful, because you see that actually the data doesn't always look the way that you were expecting it to look, or maybe the data is impacting the way that things function in the organization. And so it's important to be able to extract that back somehow, if possible.
Yes, what we usually like to do is at least the first 3 months after we deploy an AI application, we keep close monitoring and even modifying our models and making changes. For example, if we're launching a recommender system, we do A/B testing. We have a certain percentage on our system, a certain percentage in another kind of recommendation, and we adjust from there. Or for example, you're doing forecasting. You compare the results that you're forecasting with the results, the real results that happened, and you adjust your model with that. It's a continuous learning. Remember, this is not a solution that you're going to deploy once and it's going to live there forever. So you need evolution.
Okay, other questions?
We talked about the ethics of the algorithms that the process data and the AI of that, but my question is more about the actual data being collected, and I was wondering, is it possible, whether it's manual or with an automated process, to determine the data has been collected in either illegal or unethical way?
Not
Yes.
true.
Unless they put a metadata saying this is illegal, I have no way to know.
There is.
Or do you just like, basically the question is, do you just trust the data is like, you don't have any way to know that? That could be the answer, but it's just a question.
This is why you usually would like to have a very close loop with the organization, because that also helps you understand how they get this data and so on. There is, at the intersection of AI and software engineering, there is a sort of data provenance and data tracking research area that's been developing, where people basically try to understand, if you get a data set and there's certain records in there, how were they generated? For example, were they generated by an automated system or by a person, and so on. It's a very hard problem, and it's very much research work in progress, but at the moment there's no like really good turnkey solution.
Yeah, so basically the responsibility would be more on like some regulators or something else to make sure to catch these things in process, and not the actual AI developers who get the data and kind of have to trust that it's been fine.
Yeah.
I mean, typically, and I've worked in a lot of data governance, typically there's a signatory that's ultimately that data's owner, and it comes down to them. It's that individual or those individuals that are either working in legal ways, or they're treading into territory that's not so good.
That's right. That's why I was asking to sort of like having a second layer of defense, saying, hey, I'm processing data and I can actually see that something wrong there.
Yeah.
But so far I see that it's just work in progress, basically.
Yeah. And I think as developers and people that build the systems, we all have a responsibility to say, this is wrong, and to step away from that. And I mean, that's happened recently within Google, with the Pentagon wanting to work with Google, and it's happened certainly with other companies that I've been involved in as well, and people have just been like, I just don't want to be involved with that. Or here's a problem, and then that escalates up, and the big discussions happen even above the data owner's head as well. It's an interesting question in 2018, right? We're coming right to the end now. Let's do one more question. Let's do it at the back, Julia. Julia, let's do that person at the back. Because too many men have been talking.
Okay.
Thank you.
Hi, I had a question regarding like more the end user. Do you see a need to get feedback or provide feedback, not for processing back into it, but just to explain these results and adoption or acceptance of these machine learning answers that are coming?
Well, I think that from the user experience perspective, might be a good thing. For example, if you go to a page like, I don't know, the Amazon website, and you get a list of recommendations, you like as a user to know why this was recommended to you. And in fact, Amazon tells you because other users like you, because people in your neighborhood bought this. So I think that users like to know why things are being said to them. I don't know if we'll be overwhelmed from some users, but I particularly think that you should never try to hide the AI. You should be open, and in fact, for me, the AI should have even some kind of, I'm a little crazy, like some kind of personality. I like the idea of thinking in the AI as something that really can recommend and give you feedback, and not make you think that there is somebody in the other side taking those decisions.
I'm going to ask one more question that did come from the SAP crowd as a sort of a finale, as it were. And this is taken verbatim. What do you think of the claims that software engineers will be obsolete within the next 30 to 40 years? But it's interesting to me that the question was asked, because this is, you know, what's the potential of AI? Is it just going to get us all out of the way, and there's going to be one guy in the corner with a box, you know, in the future? I don't think so.
No. Okay, you are the futurist.
Yeah, I'm the future. I don't think so. I don't think so. I don't think that. I think that your developer jobs are safe. I think we're all going to evolve, right?
Yeah.
I mean, I don't know what you think.
No, it's going to evolve. That's
Yeah.
why I also think the same. I don't think so. It's going to change completely,
Yeah.
but it will change. I mean, it will evolve a little from the way we were working before to the way we will be working in the future after 30 years. It will evolve, but it won't go.
Yeah.
Definitely not replacing people, but I'm sure many professions will evolve.
Yeah.
And that's a good thing, right? I mean, professions have evolved in the past, and I think we're all sort of better off for that. And you know, our software engineer is going to disappear. I don't think so, but maybe their job is going to be very different. Maybe they'll be talking to their AI and say, you know, solve this part of the problem for me, and I'll solve this other part of the problem, and that'll be a good thing, would make us all more efficient.
Yeah.
Yes, I totally agree. You didn't have your debate here.
Yeah.
So basically, and if you think about software engineering or any other profession maybe 50 years ago, see how much has changed so far, how much has evolved. Well, the same thing is going to happen. Maybe it's going to be a little faster, the evolution, because each time technology evolves faster and faster and faster. But people continue here, continue to do things, and as the change happens day to day, you don't notice it. But think about 50 years ago, computer science.
Yeah. When I was, I left school with no qualifications, but I was good at computers, and I didn't have a chance to flex that at school. My mother and father, they sat me down and said, right, you can't just be digging holes for a living. That's literally all I was doing, laboring. And they were like, what would you like to do? It's like computers, because I knew that I'd always have a job. I think if you work in data, I think if you work in software platforms development, I think if you work in enterprise software, I think you're still going to have a great, abundant future. You're still going to impact millions of people's lives, and you're still going to have to come to work tomorrow. So I'd like to say thank you very much for your attention. I'd like to say thank you to Doina, to Carolina, and to Sawinder. Give them a big round of applause. Thank you. And I think, Sawinder, you're going to be giving a presentation. I think there's like a 10, 15-minute break now, so take a quick rest break and do come back promptly. Thank you very much. Cheers.
Thank you.